What we'll do first here, Dan, is talk a little bit about what you think some of the security trends are that are coming up.
All right. So the big trend that I think that is going to start up is God, you can just lose all your data really quickly.
Yeah.
We keep trying to make it so that no one ever gets anything, but if they get in, it's the end of the world. Mm-hmm. And the first big trend that I think is going to start is that's going to slow down a bit. We are going to figure out architectures that lose money at a or lose data or money at a not all of it at once rate.
Right.
And that's going to require a lot of really interesting re-architecture of our systems.
Mm-hmm.
Search works very differently when something on a remote trusted side needs to figure out the top 10 or 100 or 1,000 documents. Mm-hmm. But you don't necessarily need all million documents online ready to go.
Right.
And this is something that we've seen work very well in the financial world in various contexts. You can get $100, but you can't get $1 million.
Right.
And I think we're going to see that become a real trend in information security.
Yeah. I think you're absolutely right. More and more what we've been seeing is, I'm not going to say there have been fewer exploits, but more and more cases where applications are just being used in ways that you didn't anticipate, abuses of applications. And it's only defined as an abuse when it's used in a way that you consider derogatory, but in the course of designing an application, you just kind of assume that it's going to be used in the way that you originally intended. So more and more, I think you're absolutely right. And you mentioned like ATMs, you're limited to what you can take from an ATM, but that next step is, well, what if you can go to 100 ATMs at the same time and before those actual transactions go through? So I think it's going to the next step.
Which of course was a thing that happened.
Yes.
We had a major ATM thing where I think it was like a couple hundred ATMs were hit within seconds of each other, and the information that they shouldn't all provide the information ended up getting not distributed fast enough. So it's like a $17 million loss. Attackers are quite clever. You have to be able to adapt.
Yep, be able to adapt. Agility and security is one of the main themes of that capability.
Yeah, this is not a thing where you're one and done. No, you've got a cat and mouse thing. When we're out dealing with these ad fraud guys, it is constant cat and mouse.
Right. I don't think it was related to the same subject, but we were chatting a little bit earlier, and you said something about it took hours to find the problem and then 6 months to solve it.
Oh yeah, no, I was saying a few years ago I was involved in this giant bug fix to the internet, and I had the privilege and entertaining experience of consulting at Microsoft at the time. So I find this bug, and they were hit because everyone was hit, and I got to be one of the few people to be on both the outside finding the bug and on the inside fixing it. And it was 2 days of work finding the bug. And it was 6 months of work fixing it. To the point where at the end of it, I'm like, man, I didn't do much at all as the attacker. That was like a distant memory.
Yeah. So that's one of the challenges that we deal with, is that the attackers really kind of tend to have the advantage, and it takes a lot more effort to try to solve it without having derogatory impact in the long run.
Well, I hate to say it, but hacking is so easy. Teenagers can do it, and they do. So the breaking part, look, if you do a bunch of stuff and you don't know what you're doing, everything falls over. On the offense side, we just define that as success. The defense side really does involve having to do a tremendous amount of work, making sure things still work after you fix the problem.
Right.
It still has to be performant, it still has to be reliable, it still has to be usable, it still has to be maintainable, it still has to be debuggable. All of these other engineering constraints don't exist on the offense side, and they take a tremendous amount of work on the defense side.
Right.
So it's the harder problem, but that's what we signed up for here. So let's play.
Yeah, good. So what other kinds of trends do you expect?
I really do expect that we are going to start extracting a lot more signals from the systems that we're building. There's a lot of companies that are building software that are really getting inside of our applications, inside of our architectures. There's a tremendous amount of work in the test universe where, if you look at a lot of software projects, they might be 1,000 lines of code and 70,000 lines of test, because that 1,000 lines of code really has to work.
Right.
Well, we've never really been taking all that test code, all those test processes, and merging it into production. Well, in a world of continuous deployment, in a world of repeatedly updating and modifying and fixing and developing software, test and monitoring is going live as well. And that information stream is turning out to be tremendously useful for security work. There are things that only happen when you're under attack. There are code paths that are only exposed when there are vulnerabilities, not that can be found during test or in isolation, but when actual real-world production data starts flowing through. It's like when you run water through a pipe, you see the water start linking. So, companies like Previty and Signal Sciences, and these guys are actually really starting to see, hey, there's a lot of data to be extracted from our architecture. Let's go ahead and use it to basically build more secure operational systems.
So are you referring to threat analytics, or is this like really kind of a nuance of that?
I think that the actual systems that we run, the code that we deploy to make our companies go, is going to have a lot more of its test and monitoring internals exposed to the ops guys. And that exposure is going to have a real security tint to it, slant to it.
So it's really beyond security, it's really just a broader set of instrumentation on the system so that we have some visibility into what's going on within.
Security is part of operations.
It
the
is.
two are not separate anymore, especially with the amount of software as a service that we're managing, the speed at which we're altering software and accepting that this is a process that continues, that is not just delivered one and done and maybe there's an occasional patch. We are long beyond the era of occasional patches. We're in the era of software as an operational thing that if it is not babysat and it is not monitored, it doesn't run, it doesn't work, it doesn't meet the customer's needs. And one of the major customer needs now is it needs to not leak data.
Right.
So, but what I see is we will start getting better signals that we're going to leak data, that we are leaking data, and especially that we did leak data. Getting monitoring and shrinking that time between compromise and loss is what's going to happen.
Yep, I think you're absolutely right. And I think still the notion of telemetry coming from applications to be able to facilitate detection of abnormal behavior is still sort of an afterthought. And so it really, as you're pointing out, it really needs to be part of that the thought process in building things. And I hadn't really thought about it the way you're describing it. That is, we're creating these things anyway for test purposes and to validate things are working as they should be. Why not kind of tie those things together? Now, do you have any thoughts on the sort of the trade-off? One of the the cardinal sins that I've heard of in the past with software is you leave debugging mode on, and so there are all kinds of indicators that are in there and perhaps backdoors that are built in. You mentioned the number of lines of code. Adding more lines of code potentially adds more vulnerabilities. Any thoughts on that?
Nothing comes for free. It is absolutely the case that as we build out our debugging infrastructure, bugs in the debugging infrastructure can go ahead and hit us. It's part of the trade-off.
Right.
But every copy of Windows in the world sends data back to Microsoft. And you could make the case, you could make the argument, oh my God, look at all this data that Microsoft is taking. What if the data has exploits? You know what? That's the trade-off. There might be issues in the data feeds that come back. But in return, they get to know what bugs are in the world and fix them. And it's part really of how you create an ecosystem that is, if not self-healing, repairable.
Right.
Yeah. Well, one of the other issues, though, is, I mean, I agree. I think we need to have more instrumentation in this. But then, what happens with the data that comes from that? We're already overwhelmed by log data, and in a lot of cases, do you just pile this into the SIM and hope that your analysts can figure out, what's the critical indicator that we're running up against some sort of bug or attack or whatever? I mean, we get buried in data as it is sometimes, and if we want to instrument our code better, we're going to be creating more data.
Well, one of the things about good instrumentation is you actually get cleaner data. We really saw this in the ad space where it's like, there's a lot of fuzzy metrics around, this thing hasn't been on the page long enough, and that thing, bounced around too much. Maybe we should call this good or this bad. And we got to replace all that with, yeah, the browser never does this when it isn't a bot. Like, hey, let's find some guns and see if there's some smoke coming out of them. So better instrumentation can really go ahead and take right now what's an ugly problem and just give you the clean answers. Zane Lackey, who now runs Signal Sciences and used to run security over at Etsy, has this great set of slides called Attack-Driven Defense, one of my favorite decks of all time. And he's basically showing, look, here are errors that only happen in the time period after an attacker has found a vulnerability, but before they've successfully exploited it.
Right.
These bugs, they only happen when the SQL engine is breaking. If this bug happens, file the bug. They got it to the point where they had Splunk auto-filing critical bugs, and it was always accurate. That's where the world is going towards.
Right, right. See if I'm interpreting this correctly. I think one of the things that we've been finding is that the more and more you can direct your analysis toward anticipated actual attacks, and even understanding the motivation or the types of things that attackers are doing, trending in the environment, will help you to understand what data is really valuable and what's perhaps just bit junk.
You need to realize you're playing a game. This is player versus player programming. But guess what? It's your network. You get to set the rules of the game, and you get to cheat. You get to say, hey, you guys are playing on my battleground. This is my environment. You get to make those rules, so make them.
Yeah, very good. Make the rules. So what are your thoughts on threat data sharing?
I think it needs to get a lot more agile. I think we need to be a lot more open with it. There's a model where we say, we're just going to give all our data to this one central group and just trust that they'll figure out how to distribute it. And everyone wants to be that one central provider, and no one wants to share. Everyone wants in and no one wants out. And don't get me wrong, it's not that the information sharing patterns aren't helpful. It's just, I think, as a trend, where I think we're going to go is I think we're going to go towards a lot more distribution and openness. The data that's going to be out there about threats is just, we're just going to have to accept that in some instances, the bad guys know that we know. Because it is worse that the right good guys don't know.
Right.
And that is really what we do when we're talking about open disclosure of vulnerabilities. You could have a world where we found, the 5 or 10 most interesting parties that had a particular vulnerability, and we're like, psst, you really need to patch your SSL stack. We could do that. And the odds that we would get enough of the SSL stacks are zero. We wouldn't. If you want to actually fix certain bugs, sometimes you just got to talk openly about it. So I really think that we're going to see a trend towards what in the past were going to be forms of threat data sharing that we shied away from. Certainly in the ad space, we've been talking about, look, there are some domains, there's just bots there. And we're just going to tell you who they are. And at one point in time, we were like, maybe we don't ever want to share that. And now there's a realization, we need to start talking about our problems. You can't manage what you can't measure. And interestingly, you can't predict who needs to be able to do the measuring.
Yeah, I think you're right. One of the reasons we do this program is partly because we feel the need to try to get a larger audience in terms of understanding what the threats are, what activities are taking place. And you're right, there's a trade-off between making it publicly open versus trying to keep it closed to a closed group. But as I think you're pointing out, your opportunity for distribution, if you're trying to do it in a closed community, is much more limited. And the attackers know. They know what attacks they're performing, and they know what things block them. And so ultimately, they've got the insights. We need to try to get the good guys with more insights.
You got to change the rules to benefit us. That's our big advantage. We actually get to talk to each other. We get to talk to each other openly. We get to make changes first. Like we actually do have huge teams of people who can do things if they know they can do it. secrecy doesn't necessarily scale. Now, it doesn't mean that everything should be public, because it shouldn't be.
Yeah.
Doesn't mean that everything needs to be a big, loud hoo-ah about whatever, because sometimes it's great to just fix things quietly. Let me tell you, I've
Right.
done the big thing. I like the little thing too.
Yeah.
But I really do think, particularly with threat data, we need to really, really start evaluating when we have it. Could there be more good done if we were open with it?
You know, you mentioned, go ahead, Matt.
Well, I was going to step in and say, what are your thoughts on if the data is truly open, as you're saying, and it's more of a distributed where everyone can potentially be a source of that threat data? My concern would be vetting of that threat data. I've seen good intel and I've seen terrible intel.
Oh, it's
And if
true.
everybody's feeding from all of the pools at once,
Yeah.
you're going to have your SOC, flipping their lid over the number of false positives you keep tripping.
So raw. I'm mostly referring to raw intelligence.
Okay.
Being a thing that's more open. The absolute problem, when you're entirely correct, when there's too many sources, there's too many opportunities for people to inject back data. There's a really fun attack class where what you do, people are saying, oh, there's lots of IPs on the internet. So if a few of them are attacking us, let's just block them outright, and whatever, they can go away. And so what someone does, they pretend to be the internet's DNS root servers. Like, and the internet's DNS root servers are attacking you, so they get blocked, and then 18 hours, the network goes down.
Yep.
So you're absolutely right. It's just the ability to develop vetted intelligence is seeded on there being the availability of raw intelligence. I can't tell you how many. There are entire attack classes that are not public, and no one can even start addressing defenses for them until they become at least somewhat public.
Right.
Okay.
That's absolutely true. Yeah. And we've definitely seen cases where the attackers realize that there's threat intelligence being developed about them. And so they make a deliberate activity to diversify the resources they use. So rather than using a command and control server as they attack an organization, they'll use 10 different command and control servers and build that diversity into their attack, so that that piece of threat intelligence, you may report there's a command and control server at this IP address, but it only worked for that one attack in that one time in that one place. And for everybody else, it's something different. That information is really useless in the threat intelligence world. So those kinds of things, you're absolutely right.
You have to have enough distribution of the information so that you don't get the elephant problem, where this guy has the leg and this guy has the tail and this guy has the ear. No one knows that there's an elephant there because no one's talking.
Yeah.
And I really do see that kind of situation happening. Now, how do you, the big threat, of course, is that if everyone is seeing the elephant, the bad guy can see that everyone is seeing the elephant. But maybe that means they don't do the attack in the first place.
Right.
Maybe they're afraid they'll get caught because they're seeing themselves getting caught.
Creating a deterrence is a very positive thing. Absolutely. So bringing it out to the public, I think, is a very a helpful aspect of this. So what do you think is the solution? How do we get a more open sharing environment?
I'm not sure. I wish I had some great and easy answer. But what I can tell you is that we have to start actively monitoring what's working and what isn't. A lot of people like making analogies in security to biology. Oh, why don't we have a digital immune system? Yeah, the actual immune system works. It destroys a whole bunch of stuff, but it's okay because we don't know this. We'll grow new stuff. It doesn't work like that online. Okay.
Yeah, good point. Yeah, we haven't tackled that healing challenge yet.
But look. It's not that biology to learn from, it's medicine. Because medicine had a bit of a quackery problem where there were a lot of treatments that didn't work. And I'm not going to say the InfoSec industry has that problem, but I'm not going to say it doesn't have that problem. There's a lot of testing and validation that I think we need to get investment into. And it is the kind of thing where I don't even know if market forces are going to be sufficient in order to fund this. But the value, I think, to the global economy of really funding, hey, let's run a defense for 6 months and run it on a similar population only have it be absent. Let's have a placebo, a control group, and an experimental group. Come back in 6 months and see if there's a difference in infection rates. This kind of work is actually a good thing to do. And it is not the kind of thing we're doing in information security.
Yeah.
So I think the path towards any of this stuff working is actually investing in finding out what works and what doesn't. And it's going to be expensive. It's going to be really expensive.
Yeah.